Hello, I'm Mike, and this is ServoQuetsch, my entry to the FreeCAD Community Design Competition 2026. In my opinion, a pinch valve needs at least 3 parts. A valve body that holds the tube and keeps everything together, an electromechanical device, aka some motor that exerts the force, and a moving part that does the pinching. Starting with the motor, I decided on using an RC servo. You can see the model here. I used the 25 kg version, which might be a little bit of an overkill, but I found it quite as a bargain of less than 12 euros here on Amazon in Austria. An RC servo has its own bearings. This one even has metal gears, so the only thing you have to do is fix the servo in place and you're good to go. Furthermore, it can be controlled with standard libraries such as the internal one of the Arduino platform. For the design process, I always start with a file that I call V in my projects. V because it contains all global variables. I have some master sketches there that I use mainly for documentation, and I have a small script called sketch2var that goes through all these master sketches and copies all named constraints to the var set and links its values. So each time I change one of these master sketches, the variables in the var set are changed automatically, and so are all my parts of a design that take the global variables from this V file. So here I have my master sketches, the valve from the top, the servo put in place, the valve from the side, and based on these master sketches I did the design of the valve body. You can see the cutout for the servo in front, a feature for holding the tube here with a cutout allowing for the pinching. In the back we have a hole in the middle for easier assembly and 2 mounting holes, one below and one at the top here. I originally also added a cutout here for some zip ties to hold the tube in place, but in all my tests the tube was held perfectly in place just by friction. So I did not use these cutouts, but I left it there just in case. For the final part, the pincher, I go back to a master sketch, and there the outline of its shape is defined. The pincher will be rotated by the servo. Here the pinching should be done over an angle of 30 degrees. The contour of the pincher should go from a pinch starting length to an end length, and this fully pinches down the tube. Here this final width of the pinched down tube is defined. This width is smaller than 2 times the wall thickness of the tube, but we have to account for some compression and also for the clearance of the servo cutout. In part design, you can see the shape of the master sketch here. Here is the start length, here the end length, along the angle of 30 degrees. I interpolated in between with some arcs. For connecting the pincher to the servo, the shaft has this spline consisting of these little teeth. 3D printing a matching part to these teeth is nearly impossible, so I decided to use the supplied servo horn and do a matching cutout for the horn instead. You can see it here. For assembly, the servo horn is first trimmed in length and then put on the servo shaft. Then the pincher is put on top and both are screwed down with the screw of the servo, and this holds them perfectly in place. I printed two versions, one on an Anycubic Cobra 2 Pro with a 0.4 mm nozzle and a second version on a GD Q1 Pro with a 0.6 mm nozzle. For assembly, we only need the servo, the printed parts and two zip ties. For controlling the valve, I used the internal servo library of the Arduino platform. For opening, a value of 0 is sent. For closing the valve, a value of 65 is used. From the design, one would assume the value of 90 for closing the valve, as it closes at a 90-degree rotation, but this servo has a little different timing than the one set by the default values of the Arduino library. If one likes to have 90 for closing, this could be easily changed in the servo initialization. I used an Arduino Nano clone and an external 5 volts power supply for testing. I had this nice Schottky diode lying around, so I included it for reverse polarity protection, and furthermore I added a buffer capacitor on a small breadboard for the testing. Here is an overview drawing showing the outer dimensions of the valve. And finally, you can see two valves side by side mounted on a wooden board. The internal mounting holes allow for compact installation of multiple valves. Thank you all for watching, and a special thanks to all FreeCAD developers for their amazing work.